probability. Normalizing a function to make a probability distribution function. Example. Okay, so our function is going to be 3x times 4 minus x. This is defined on values for x between 0 to 4, and then it's going to be 0 otherwise. So just to see a quick graph of this, we have 0, 4, we have x, f of x. So from 0 to 4, you have a parabola, and then it's going to be 0 outside that. So graph's going to look something like that. The max value is going to be at 2 here, 6, 12. So we want to make, and so we want to turn this function, which is non-negative, so turn into a probability addition. So we need to find what this area is and make it 1. So that's the process. Once we do that, then it will be a probability distribution function. So first step is find the area under the entire curve. So we need to compute this. Area under the entire curve, we want to figure out what that is. And then, so since we have a piecewise function, the relevant piece is going to be from 0 to 4. That's where we have a non-zero area. And then these other two pieces are going to end up being 0. So from negative infinity to 0, our function is 0. So that one's just going to drop out. And similarly, from 4 to infinity, our function is also 0. So that one is dropping out. So the only piece that's contributing anything is this one. That's one we're going to pay attention to the rest of this computation. So we need to distribute this. So this will be 12x minus 3x squared. So we want to find the area under the curve from 0 to 4 of that. The antiderivative here is going to be 6x squared minus x cubed. And we want to evaluate that from 0 to 4. So we just plug that in. So we have 6 times 4 squared minus 4 cubed. That's the upper limit, minus 6 times 0 squared minus 0 cubed. Okay. These terms here are both going to be 0, so we're going to end up subtracting 0 from whatever this result is. This one, this is 16, and this is 64. So 6 times 16 is going to be 96 minus 64. So that gives 32. So we have 32 minus 0. So our total area of the original function is 32. All right, so to make a probability distribution function, what we do is we divide by the area computed and then multiply by the original function. So this will give us a probability distribution function, f hat. And so the formula for this is going to be 1/32 3x 4 minus x, again on values of x between 0 to 4 and 0 otherwise. So the effect here is that we've taken this graph and we've adjusted the height down to 12/32. So that peak is now 12/32 here. Let me rewrite this. So we've just scaled it down. That's really all we're doing with this. Just to show that this is in fact the probability distribution, I'm going to integrate this function and show you. So what is 0 to 4? Again, the pieces outside of it are still going to be 0, so we want to see what this ends up being. Okay, so this is going to be 1/32 0 to 4, and then it's 12x minus 3x squared dx. So this is antiderivative of 6x squared minus x cubed from 0 to 4, but this whole thing is multiplied by 1/32. So this will be 6 times 4 squared minus 4 cubed 1/32 minus 1/32 times 6 times 0 squared minus 0 cubed. Again, this part is 0. Here we have, again, 16 times 6, so that's 96. This is 64, so 96 minus 64 minus 0 times 1/32. So 96 minus 64 is 32/32, which is 1. So just to confirm, this function is now a probability distribution function.